Okay, next, properties of cross product. Okay, example, standard unit vectors. Okay, standard unit vectors is a unit vector that show the direction of vectors given. Okay, so for y-axis, the direction in the standard unit is a vector I. Okay, is vector on the x-axis. The unit vector here is I vector. On the y-axis, the unit vector is given by j. This is a notation used for standard unit vectors. Okay. And the z direction is given by unit vector k. Okay. So the component of unit vector I is given by 1, 0, 0, where 1 is the magnitude 1 unit in the direction of I. Okay, j is given by 0, 1, 0, where the second component is 1 unit, and k is given by component 0, 0, 1. Okay, this is standard unit vectors, right? Okay, this vector has length 1, so this is standard. Okay, the length of a unit vector is always 1 and lie along the coordinate axis. So the coordinate for 3 dimension is x, y, and z. Okay, where I is in the direction is a unit vector for direction on x-axis, j direction of y, and k is a unit vector for the direction of z axis. Okay, they are called standard unit vectors in the 3 space. 3 space means 3 dimension. Okay, every vector v in the component for vector v, let's say v1, v2, and v3, every vector v in the 3 space is expressible in terms of I, j, and k. Okay, for example, so any vector in the any n space v, v1, v2, v3, so we can write in the form of standard unit vector. Okay, where v1 can times by a unit vector of I plus v2 times by component unit vector of j, and v3 times by unit vector of k. So we can express vector v in the form of v1i plus v2j plus v3k. Okay, for example, let's say vector v is given by 2, minus 3, and 4, and we can write in a standard unit form as 2i minus 3j plus 4k. Okay, ki cross product j, ki cross product j is given by component 1. So this is the first component given by determinant of 2 times 2. Okay, and then second component given by determinant 2 times 2 of this one, and component k given by determinant of 2 times 2 of this matrix. Okay, so we solve this one, it becomes 0, and this one is 0, and this one is 1. Okay, so I cross product j is obtained from I cross product j is obtained from I, j, k, and first component is component I is 1, 0, 0, component j is 0, 1, 0. Okay, so find I cross product j. So we got this one. So we got this one, and then finally solve this one. We have, by using this determinant of this, So we have 0, 0, 1. Okay, 0, 0, 1, K. So I cross product J equal to K. So how do we get this one? In order for you to remember, we use the circle of this one, which is clockwise. Okay, clockwise, using a clockwise rotation, clockwise circle. I cross product J become K. K cross product I become J. J cross product K become I, and so on. Okay, but if we cross product anti-clockwise, it become negative. I cross product K become negative J. J cross product I become negative K. So this is what we got. Okay, this is what we get. But the standard unit vectors cross product with itself always 0. Okay, for I cross product I is 0, J cross product J is 0, K cross product K is 0. Okay, for I cross product J always K. I cross product J become K, J cross product K become I, K cross product I become J. But J cross product I become negative K because it is anti-clockwise. This one also the same. Okay, next is area of parallelogram. So what is parallelogram? Parallelogram is a space or an area which is given by a three dimension on the x, y and z axis. Okay, so so uh, the shape of an area which is covered by a two parallel line like this, parallel line. Okay, this is called parallelogram. Okay. Okay, example, area of triangle. Now find the area of a triangle determined by a point P given by 2, 2, 0, P2 given by negative 1, 0, 2, and P3 given by 0, 4, 3. So now we want to find the area that is covered by these 3 points. Okay, so how do we do this? So the area of a triangle covered by these 3 points given by this. So this is the P1, P2, P1, P2 and P3. So this is P1 to P2 and line P1 to P3. And the parallel of the lines parallel of the line P1, P3 and P1 to P2 given by this line. So area covered by this parallel line is called parallelogram. Okay, so now we want to determine the area of this parallelogram. Okay, first we find the component from P1 to P2 and component from P1 to P3. The component P1 to P2, P1 to P2, take this component from P2 minus component in P1. So we obtain this. And then component in P3, minus component in P1, we get vector of P1, P3, like this one. Okay, so the area of this parallelogram is given by the cross product of P1, P2 and P1, P3. So we find the cross product of these two components. So using the formula of cross product, so we obtain this formula. Okay, you should try to find this on your own. So we have obtained this component. Okay, so now the triangle of this parallelogram is half of the area of parallelogram. So we have A, the area of this triangle is given by half, and the length of the cross product of P1, P2 and P1, P3. So we take the length. Okay, the length of P1, P2 cross P1, P3 is given by the area of this parallelogram. Okay, so try to calculate this. So the answer is half times 15 P1, the length of P1, P2 cross P1, the length of this one, using this formula. Okay, using this formula. So the length is 15 over 2. Okay, next. So the scalar triple products. So this is the symbol of scalar triple product, which is U dot product bracket V cross product W. So we call this notation as scalar triple product of U, V and W. Okay, let's say U, V and W is a three dimension. So we have U must have three components, U1, U2 and U3. V, V1, V2, V3 and W is W1, W2, W3. So the scalar triple product of U, V and W is given by the determinant of U1, U2, U3, and then the second row is V1, component of V1, V2, V3, and third component is W1, W2, W3. So we find determinant of this vector. Example, scalar triple product. Calculate the scalar triple product of U dot V cross product W of the vector given by this U, V and W, having this one. Okay, so the scalar triple product of U, V and W is given by, so we arrange the U in the first row, the component. Second row is the second component of V, is V 1, 4 and minus 4, and W is the third component, which is 0, 3 and 2. Okay, now find the solution of this scalar triple product. You find this determinant. So the answer is 49. Okay, try to calculate the determinant of this 3 times 3 matrix. So finally the answer is 49. Okay, next is finding the components of a vector. Okay, so now let's say we have the lines of vector from these 3 dimensions given P1 and P2, okay, from initial points. Okay, so in the vector form we write OP1 having this one and OP2 given this vector. And then if we were to find a vector or component for P1 to P2 vector, so we use the method, which is the components of the vector V given P1 to P2 with initial points. The initial points given is P1 from initial points, meaning that from the initial point here, the component at P1 given by 2, minus 1 and 4, and the terminal points. So the last the end point of this arrow P1, P2, we call this terminal point, is given by, from the initial point, it's given by component 7, 3, 5 and negative 8. So to find the component of vector P1 to P2, we take the terminal point here minus the initial points. okay, from terminal points minus initial points. So we have 7 minus 5 minus 2, 5 minus 1, and negative 8 minus 4. Okay, so using this, we are able to find the components for a vector P1, P2. Okay, the Cauchy-Schwarz inequality. So this theorem of Cauchy-Schwarz inequality said that for all vector u and v in R space n, in R dimension or in n dimension, space n dimension, the u dot product v is always less or equal length u time product of length u and length v. So this has been proven, and this is called the Cauchy-Schwarz inequality. Okay, now angle between vectors. Okay, so we have learned about angle between vectors earlier. So if u and v are vectors into space or 3 space, and theta is the angle between u and v, then the dot product or Euclidean inner product. So this is another name for dot product. Sometimes we call it Euclidean. Euclidean is the space or the dimension in any space provided. Okay, inner product u dot v is defined by u dot v equal length of u time length of v cos theta. Okay, with condition u not 0 and v also not 0, and u dot product v is always 0 if vector u is 0 or vector v is 0. Okay, from this definition, from this formula, we find cos theta as this formula. So cos theta, bringing this length to the left side, we have cos theta is u dot v over length of u times length of v. So this is the formula if we were to find the angle between two vectors. Okay, example, consider the vector u and v given by this component. Find u dot product v and determine the angle theta between u and v. So u dot product v, as usual, we use the u dot product v multiplied by the component u dot v1 plus u2 v2 plus u3 v3. Okay, dot product is component. Okay, so we have 2 times 1 plus minus 1 times 1 plus 1 times 2. Okay, and then find the length of u and length of v. Length of u, so we have this one. So using formula of length of u is 2 square plus minus 1 square plus 1 square. Okay, and length of v is 1 square plus 1 square plus 2 square. Okay. Okay, so cos theta is u dot v over length u times length v. So u dot v of 3 over length u, this one is 36, and length v also, this one is 36. So answer is 3 over 6. 36 times 36 is equal to 6. So 3 over 6 is 1 over 2. Okay, so 1 over 2. So theta is cos, using your calculator, cos inverse 1 over 2 equal, theta is 60 degrees. Okay, norm of a vector. So what is norm of a vector? Norm of a vector is another name for length of a vector. So the length of a vector u is called the norm of u and denoted by the symbol that we have learned earlier as length of vector u. Okay, into space, u is written in component u1, u2, and the length of u is given by third u1 square plus u2 square. Okay, in 3 space, component in u is given by u1, u2, and u3, and length of u is given by or length of u or norm of vector u is given by third u1 square plus u2 square plus u3 square. Okay, a vector of norm 1 is called a unit vector if p1 and p2 are 2 points in 3 space. Okay, then the distance d between them is the norm of the vector p1, p2. So we learned earlier the component of p1, p2 is given by component of p2 minus component p1. So we calculate component of p1, p2 first. Terminal minus initial. Okay, and then the distance of or the norm or the distance p1 p2 is given by third component d square plus component d square plus component d square. Okay, so this is the formula of the distance. We don't call this length because this is the distance between point p1 to p2. Okay, or the vector from initial point p1 to terminal point p2. Okay, example, the norm of the vector u given by -3, 2, and 1 is given by this formula, minus 3 square plus 2 square plus 1 square, which is 14. Okay, now the distance d between the point p1 and p2 is, so the distance d is given by point this minus point this. 4 minus 2 square plus minus 3 plus 1 square plus 1 minus 5 square. So the answer is 44, which is 2 third 11.